Okay, so here we're looking at the second video on forces. Now we're going to start looking at moments and how they affect things in terms of rotational motion. So the turning effect of a force is essentially what moments are. So a moment, So a moment is for that thing there, okay, the moment is the turning effect of a force. Now, if you look in the dictionary, you probably would find that definition, okay, in the dictionary, but it's better probably if you say it is, it's the product of the force and the perpendicular distance of the line of action of the force from the pivot. Okay, much clearer that that description there. So essentially, if you're looking at these two pictures here, imagine this is a pivot here, some sort of hinge. We have a stick sticking out from that hinge, and someone's applying a force with their thumb. Okay, the force in this case is perpendicular. Can you see there's 90 degrees there between the force and the distance of the force, which is this line there. That's what it means by line of action. Okay, so the line of action of force is straight down there, and we're perpendicular distance from the pivot. Okay, so the moment in this case is just a product of the two things there, where if this one is F and if that one there is D. In this case here, the force is no longer perpendicular to the stick. Okay, it's no longer perpendicular to that stick. So we still need to do the product according to the definition. Okay, and that is the line of action of the force. So that's that line down there. That's the line of action of the force and the perpendicular distance. So in this case, if I know X and if I know the force F, then the moment is going to be force multiplied by cos theta times X. Okay, so the actual force has changed a bit because of that angle, the line of action of that force. Has this made it better? No, it's actually made it worse. It's harder to rotate the stick because you're pushing at an angle. It's like walking up to a door and pushing it at a big angle and trying to get the same sort of speed of rotation. Formula and unit, okay, moment is equal to force times distance. I'm just going to make sure that that is perpendicular. What's the unit? Well, you look at the formula there, Newton meters. Now, you better be aware that essentially it could be similar to energy, which we'll look at later, but be aware that it's 90 degrees, whilst energy is the force and distance are in the same line. So here we've got a couple of examples where we've got someone with a spanner, a wrench, on the car. Now, when you're using a wrench or something like that, you can see this is quite a long wrench here. The reason why that is because it's much easier to have a large distance as opposed to a small distance, because you're looking at the product of two values. And if you multiply a large distance multiplied by the force, you get a much larger outcome. Now, what we've got here, so if a person can push with a maximum force of 250 newtons, what's the moment that can be applied to the wrench to tighten the nut? Hence, calculate the moment applied to the nut. So, moment is equal to force times distance. So what is the force in this case? It's 250. When we're going to multiply that by 0.30. So that would be 75 Nm. Now you notice that I've put the answer as 2 sig fig, and it is 2 sig fig anyway if you look at the calculator, but that's because we essentially got 2 sig fig in our question.